I'm ready, mister.
Thank you. Okay, so we're going to build on the ideas we've been getting on these congruent triangles and go one step further. So here's the basic idea. Students will be able to prove various other parts of a triangle are congruent. How can you use congruent triangles to prove angles or sides are congruent? So I kind of want to show you how this works. So when we first started working with triangles way back in section 4.1, we noticed that there's four parts that there's 6 parts that triangles have. They have 3 pairs of sides and 3 pairs of angles that you need to show that are congruent. And so that's what we started out by doing. So let me just show you the basic idea that we're going to get into today. Let's say we have a triangle right here, and we'll just call this triangle A, B, and C. And now let's say we have another triangle over here, kind of like this. H, R, D. And let's just say we're doing some of our stuff in our problem, and we determine that this side is congruent to this side, and we determine that this side is congruent to this side, and someone comes along and proves that this angle here is congruent to this angle. Well, a very natural thing to do right now, can you stop? We're doing this now. Alright. Okay, alright. So I think the natural thing would be to say that these 2 triangles are congruent. And hopefully you can state the postulate. Go ahead, Adrian, why?
Will this be on TV? I mean, YouTube?
Eventually, I hope it will be.
Alright.
Okay, so anyhow, we have side, angle, side here, and we have side, angle, side. And so we could say the 2 triangles are congruent by side, angle, side. Well, now that the 2 triangles are congruent,
what does SAS mean?
are you sure you want to see it on? I mean, what do you think it means?
SAS?
It means side, angle, side.
Oh, the side angle side stuff.
Yeah. Okay. So now the thing is, because we know this, the triangles are congruent, we can automatically say that this side is congruent to this one.
That's easy.
And we could also say that this angle now up here is congruent to this one over here. And we can also say that this angle here was congruent or is congruent to this one over here. And that's because all the corresponding parts are congruent now. All 6 parts. So all 6 parts are congruent. Okay, so the theorem that we're going to learn about today has to do with this idea. It's called corresponding parts of congruent triangles are congruent.
Congruent.
Yeah, how about that? So I'm going to go through here fairly quickly. So this is our theorem, and we're going to abbreviate this theorem CPCTC. Okay, and so you're going to see this abbreviated like this, CPCTC. And again, we just use capital letters here. Corresponding parts of congruent triangles are congruent. CPCTC.
Where's the A?
We don't have every single little word in between, just the big words, okay? Just like, you know, the way titles work. Okay, so in any event, pretty easy idea, I think. And corresponding parts of congruent triangles are congruent. Bingo. So let's look at a problem. What we're going to do lots of times is the first step is to prove that triangles are congruent, and then after that we use corresponding parts of congruent triangles are congruent. So how can we prove that angle A is congruent to C?
Well, first off, we look at that chart, and on the left side, there is side, angle, side.
No, there isn't.
Angle, side, angle.
And I do not know that that angle is congruent to this one. I don't know that.
Oh no, what are you trying to find? Oh, A and C.
I'm trying to prove that A and C are congruent. So
what you want to do is look at
well, please tell me.
Side.
Yeah, I'm looking.
This side.
Mm-hmm.
And then look at that side of this one, so it's side, side.
So there's the
And
side,
then
side.
The angles. Side, side, angle.
Side, side angle. Hold up. Side, side angle does not prove triangles are congruent. We've already been through that. We could use side, side, side because this side is a shared side. It's the same side for both triangles. So there's a side here, and there's a side. I'm sorry, what did you say?
I had said side, side, side.
No, you didn't.
I swear I did.
No, you always had an angle involved. Okay? Pretty sure, and if you want, we can rewind it and watch it on YouTube sometime, okay? Alright, but not right now. So the first step, we're going to say that triangle, step one, would be to say triangle ABD is congruent to triangle CBD. And once we do that, and this is by side, 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 okay, that's the reason we'd use, then we can say, number two, angle A is congruent to angle C by CPCTC. Corresponding parts of congruent triangles are congruent. Yeah. CPCTC. Okay. In fact, we could even say that this angle up here is congruent to this angle down there. And in fact, we could say this angle right here is congruent to this one over here, because all 6 parts now are congruent. Okay? So this is a typical first step. Prove that the triangles are congruent by using a shortcut method. And then the second part, use CPCTC. Alright. Let's look at a proof now. We'll do another example, and then I'll let you get started on the book assignment. Alright? So, well, we might do a few more examples first, but so I would like to prove triangle BCE. Where is BCE?
That small one with
And
the angle.
it's a small one. BCE is this triangle right here. And I'm trying to show,
How do you know that? Oh, yeah.
well, there's BCE.
Come on.
And then I want to show that that's congruent to DCE. Well, that's this one on top. And so here's the thing. I mean, let's look at the diagram so we can see where the tick marks are. Well, first of all, I do have an angle congruent. I have one angle congruent. These 2 angles are congruent.
But isn't the one smaller than those? It's smaller.
Okay, it may look smaller, but it has a single tick mark on it. If you drew this right there, it would look the same size. They drew it a little bit further out. So if you drew this across here, they would look the same size. Okay, alright, so in any event, we do have a pair of angles congruent already. So there's an angle here, here's an angle here. Now, there is a common side also. Okay, there's a common side right here. So there's a side here and a side here. But as I go down my list here, side, 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 angle, side, angle, hypotenuse, leg, okay, and finally angle, side, I don't think I could use any of these right now to prove that the two triangles are congruent. So what I will do, maybe what I can do,
I can't see that.
you can't see that?
No, we can't.
Alright, side, side, side. Side angle, side. Angle, side angle. Hypotenuse leg. Okay. This looks pretty up here on my screen. And look, I have all these snowflakes in here because it's winter time.
Nice.
Nice, right? Okay, so, well, what could I do? Maybe what we could do, here's my plan. Okay, you guys want to see this? Sometimes this takes a lot of work. I notice there's other groups of triangles in here, right? There is this triangle that's on top. You see? I could prove that that one's congruent down to here, I think. And I don't think that one would be that hard. Pretty sure I could do that. After I do that, I might prove, oh, there's some other triangles I can deal with. You see, I also might try to prove that this triangle over here is congruent to this one down here. You see? I might try to do that. And if I were to do that, for example, then I would be able to say this side is congruent to this side, and I'd have this side congruent to this side. Oh my goodness, and then I'd have a side-side angle. I don't like the side-side angle setup. The side-side angle doesn't work, right? Side-side angle, I don't want to use that one. So we got to be thinking about how we might do this. Well, that's, oh, we might be able to do side, side, side. See, so if I were to show that the big triangle, this one, is congruent, then I would be able to show that this side is congruent to this one down here. And then I'd have side, 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 side angle, side. Oh, there you go. Now we have a plan. You see, so it's not always easy to see what your plan is right at the beginning. But my plan now, I think, okay, I think it's very clear. I think what I'll do is I'll prove that the triangle on top, right here, is congruent to this triangle on the bottom, down here. Oh, see, I can't even draw straight on this pad thing. It's a lot more difficult than it looks. Okay, so I'm going to prove those two triangles are congruent. So, S step number 1. Let's take an inventory. What do we have if I'm trying to prove the black one is congruent to the red one? I have this angle is congruent to this one. Look at that. I already have an angle here, and I have an angle here. I have an angle over here. I have an angle over here. And don't they share the common side in the middle?
Yes.
Okay, so there's a side here, there's a side here. So what I need to do if I'm going to do this proof, by the way, should we do a flowchart proof?
What?
A flowchart proof. Well, let's do a flowchart proof.
Let's just
Oh, the flow chart.
A regular flowchart one.
Same.
Okay, so I'm going to erase this. Watch this. I'm going to do a flowchart proof. Okay, so angle 1 is congruent to angle 2. And I'm going to put a little bubble around that. And I'm going to say given. And then I'm going to say angle 3 is congruent to angle 4. Okay? And I'm going to put a little bubble here. And now underneath that I'm going to say CA is congruent to, by the way, what should I use over here? I'm using the black triangle first, right? Oh, hold up. BCE is the bottom. Well, I'm using the top triangle first, right? And this side matches up with this side, right? So it looks like to me I should be using CA here also. Now, the reason that I can use this is called what? Reflexive. It's called reflexive. Property. Reflexive property. So now what I want to do is use this piece, and this one. And that's going to allow me to say the top triangle is congruent to this one. Triangle CDA. Uh-oh, I'm running out of space. I need to make my bubble bigger. It's congruent to triangle, the one on the bottom. I'm going to call that one CBA. And please remind me, what's the reasons for this again?
Angle, side, angles.
Angle, side, angle. Angle, side, angle. Now, because I've shown this, I can then continue. I'm going to continue up here to a new bubble. And I'm going to say CD is congruent to BC. Oh, hang on, I should call it CB. Okay, so CD is congruent. So that gives me a tick mark here and a tick mark here, right? Now what's the reason for this one? It's our new theorem.
CPC and TC.
CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. Can you guys stop? Honestly, we're doing a lesson right now. Okay, so that look at our setup here. What do we have? We have not side, side, side. We have side angle. We have a side angle and a side angle. The triangles I want to deal with now are these two. I have side angle, side angle. This side, right here in the middle, I'm going to have to erase this. It's getting way too messy now. This side is congruent to itself. So there's your side. So we have side angle side, side angle side, and side angle side. So what I need to do is put this in my proof somewhere. And that one I can just place anywhere. I'm going to set it by itself. I'm going to say CE is congruent to CE. Okay, and there's my bubble. And I'll put the reason for that. It's the same as this one, right?
Yes.
Reflexive property. Reflexive. Okay, so now I think I have enough information. I'm going to use this piece of information. Where's my two angles at? And isn't angle 1 and 2 in here already? So I'm using angle 1 and 2. That gave me an angle. Oh, I need the side. Where's CD at? Oh, CA. Oh, hang on. Oh, here it is. I have this piece right here. That gave me the side. This gave me the angle. This gave me the third side. So I have side, angle, side now. And now the two triangles are congruent. So I'm going to say triangle BCE is congruent to triangle DCE. Okay? And now this time we would say side, angle, side. So let's look how this works. Typically when you're using corresponding parts of congruent triangles, you start out by showing one pair of triangles are congruent. That's what we did right there. Then we use corresponding parts of congruent triangles to prove that this set of triangles was congruent. So the proofs are just a little bit longer in this section. But that's basically all you do. And so I'm not going to do this one because it's similar to the previous one. And so we're going to be using this new theorem quite a bit. Now, what I want to do is have a quiz over this section tomorrow. Just this section. Does that make sense? This is called a homework quiz, basically. We're going to start having homework quizzes because too many people are waiting. Too many people are sitting in class. So my expectation for you is to work during class. My expectation is for you to do homework and to be ready for class the next day. So at the beginning of the period tomorrow, I will put basically a one problem quiz on this section. Or sometimes I might have two problems. But I'm only going to give you about 10 minutes to do it. Does that make sense? This is how this will work. Alright? So there will be a homework quiz on this section tomorrow. So please make sure you use the rest of the period. You got 25 minutes or a half hour to work on the assignment right now in class. And the problems that you do on the book assignment, those are the types of problems that you will have on the homework quiz. So if you've done this, you will do very well. Make sense? Alright, so homework quiz tomorrow. Let's stop right there.
I won. Oh man, you're taking